Hi everyone, today's lesson is on circles and ellipses, so let's get started. Let's start off with a review of circles. So the standard form of an equation for a circle is x minus h quantity squared plus y minus k quantity squared is equal to the radius squared. That is assuming that h and k is your center, so hk is your center of your circle. So basically, if I had a center that was at, let's say, 2, 3, and let's say that I had a radius of 5, so that would be all the way around like something like that with my radius of 5, my center being at 2, 3, my formula would be x minus 2, the opposite of 2. See that minus sign there? That's the opposite of 2, h being the x coordinate of my center, and k being my y coordinate of my center, squared, plus y minus k, which would, in this case is 3, quantity squared, is equal to my radius 5 squared, so that'd be 25. So this right here is the standard form for the equation of a circle. Notice that the 25 is on the right-hand side here. However, there is something called the general form of an equation of a circle, and that's if I were to multiply out these two terms, meaning if I said x minus 2 times x minus 2 plus y minus 3 times y minus 3, and set that equal to 25, and I FOILed and worked it all out, this is what I would get. And so we call that the general form of a circle. So that's the general form. Just a note, with regards to the standard form of a circle, I also could divide through by the 25, meaning if I divided through by 25 here, here, and here, I would get x minus 2 quantity squared over 25 plus quantity y minus 3 squared over 25 is equal to 1. And this is also the standard form of a circle, the equation of a circle, just with me dividing out the radii. So this is another option for you to, when you're choosing to write out your equation, because the only difference between my circle and my ellipse is that in an ellipse, my denominators are different, and my circle, my denominators are the same. So transforming an equation, this is general form, see how it's equal to 0. Transforming the circle equation to standard form, I am going to need to complete the square. So in order to do that, first I'm going to group my x coordinates. So I'm going to go x squared plus 4x. And then remember that if you have an x squared term and an x, you are going to need to complete that square. So you're going to take half of the middle term, which is 4, take half of that b term, which is 2, square that, and that's 4. Remember, whatever you add to one side, you do have to add to the other. So I need to remember to add 4 to the other side. Now keep going. We have plus y squared minus 6y, because we're grouping our x's and our y's. Take half of 6 is 3. 3 squared is 9. Equals, see this 12? I moved it over to the other side. So minus 12. If I added 4 and added 9, I need to do that here. So add 4 and add 9. So what I get on the right-hand side, let's see, negative 12 plus 4 is negative 8, and negative 8 plus 9 is 1. So this is equal to 1. I need to, now that I've completed the square, I need to factor that. So that's going to factor to be x plus 2 times x plus 2 plus the quantity y minus 3 times y minus 3 is equal to 1. And I'm going to simplify this in that I'm going to say that's x plus 2 quantity squared plus y minus 3 quantity squared, and that is equal to 1. Okay, so what I've done now is I have now I put this in standard form, and the standard form is this right here, so box that up. I do know my center, which is HK, which is this value, this value. Remember, opposites, opposites. So my center of my circle would be negative 2, comma, positive 3. This value right here is my radius squared. So if I square root both sides, I get my radius equal to 1. So what I have here is, if I were to graph this, which you should, you would go over -2, up 3. So there's that center of my circle. And then I have a radius of 1, which basically means that my circle looks something like that. Let's try another. And let's complete the square. This is, again, in general form. Just keep in mind general form, and we want to transform this to standard form. So we are going to group our x's, so x squared minus 16x, and you can do this in more than one step, meaning I can do this and then group my y's. So I'm going to take, leave a space, plus y squared plus 14y, and then I'm going to leave a space and put the 32 onto the other side. Completing the square, again, I'm going to take half of my b term, which is -16, half of that is -8. Square that, I'm going to get 64, which means I do need to add 64 to that side as well. Take half of 14, which is 7. 7 squared is 49, and I'm going to add 49 to this side. And what I've done now is I've completed the square, so now I'm going to factor. I'm going to factor this trinomial, and I'm going to factor this trinomial. So factoring that, I'm going to get x minus 8 times x minus 8, which is x minus 8 quantity squared, plus, in factoring this, I'm going to get y plus 7 times y plus 7 quantity squared is equal to, let's see, -32 plus 64 is 32. 32 plus 49 is what? What is that? 81? 81. And so what I have here is my circle in standard form. I have my radius is 8, -7, opposite, opposite. My that was my center. So this is my center. And my center is at 8, -7, and my radius, r squared is equal to 81, but r is equal to 9. So graphing this, I would go over 8 and down 7, and with my radius of 9, I would be going up, to the left, down, so my circle would look something like that. Keeping up with our warm-up with circles, something you learned in geometry, find the equation of a circle with a diameter that has these endpoints. So the endpoints are -1, 6. So we'll put that point there as -1, 6, and 5, -2. So we have this point as 5, -2. And because this is my diameter, what I have is this length right like that right here. And so my circle, actually, that being my diameter, comes around and does this. Okay, so what I need to do is a couple of things. Number one, I need to find the center of my circle. So the center of my circle is going to be around here, but in order to find that, I'm actually going to need to find the midpoint between these 2 points, and that's going to give me my center right here. So we're going to find the midpoint. And in order to find the midpoint, you're going to add your x's and divide by 2. So we're going to go -1 plus 5 divided by 2. And to find the y coordinate, we're going to add our y's, 6 plus -2, and divide by 2. So my midpoint, let's see here, -1 plus 5 is 4. 4 divided by 2 is 2. 6 minus 2 is 4. 4 divided by 2 is 2 again. So my midpoint is 2, 2. So this point here is 2, 2, which means that when I'm making my circle in standard form, I already have my center. So I'm going to go x minus 2 quantity squared plus y minus 2 quantity squared is equal to my radius squared. Now remember, radius squared is whatever my radius is squared. So I need to find this length right here, which is my radius, okay? In order to find that length, I'm going to need to find the distance between either my diameter here, find that length and divide it by 2, or just find the distance between my radii and my one point on my circle. So I'm going to do that. So the distance is going to be equal to, remember the distance formula, subtract your x's, square that, plus subtract your y's, square that. Remember the x sub 2 and the x sub 1 and y sub 2, those are just the second x and the first x. So the distance between those 2 points, and I'm choosing this point and this point, the 2, 2 and the 5, negative 2. So I'm going to subtract my x's. So I'm going to go 2 minus 5 quantity squared plus 2 minus negative 2, and that's quantity squared. So my distance is going to equal to 2 minus 5, which is negative 3, but negative 3 quantity squared. Remember, that's a negative 3 in a parenthesis, which is negative 3 times negative 3, so that's positive 9. And then 2, this becomes plus, that's 4. 4 quantity squared is 16. So we have the distance is equal to the square root of 25. Remember, always add these two numbers first. Do not take the square root of those separately, because that's not correct. So the distance between those 2 points is 5, which means that my radius is 5, which furthermore means that my equation in standard form is going to be x minus 2 quantity squared plus y minus 2 quantity squared is equal to 5 squared, which is 25. So here's my equation in standard form for my circle. One more for circles. It says write the equation of this circle in standard form. Now, there's a couple of things that you should recognize. The first thing is this is shaded, and it's shaded inside. And this outside line here is solid. So what I need to do first is I need to find the center of my circle. So the center of my circle is going to be this point, because it's going to be in between 5, 1 and 1, 1. So that's going to be 3, 1. So there's my center, 3, 1. It also means that my radius is going to be a length of 2. So the equation, so if we have center is at 3, 1, and my radius is 2. So what this is telling me is that my equation is going to start off the quantity x minus 3 quantity squared plus y minus 1 quantity squared. And then because this is a shaded in circle and it's shaded on the inside, it's shaded less than. Not if it was greater than, it'd be shaded all the way outside, like all of this space out here. But because it's shaded inside, it's less than. So that, but because it's a solid line around my circle, not only is it less than, but it's less than or equal. And then this value right here is my radius squared. So if my radius is 2, this value is 4. So what we've just found is the equation of our circle in standard form. So just for fun, I actually want you to write this in general form. So remember, general form means I'm going to set it equal to 0. So that means everything is going to be moving to the left-hand side. So we have x minus 3 quantity squared plus y minus 1 quantity squared minus 4 is less than or equal to 0. And we're going to multiply this out. So we have x minus 3 times x minus 3. That's a 2, by the way. Plus y minus 1 times y minus 1 minus 4 is less than or equal to 0. And using the FOIL method, we get x squared minus 3, which is minus 6x, plus 9, plus y squared minus 1y is minus 2y, plus 1 minus 4 is less than or equal to 0. So what I have here is x squared plus y squared. I have a minus 6x, I have a minus 2y, and now I have a 9, I have a positive 9, plus 1 is 10. 10 minus 4 is 6, so this is going to be plus 6 is less than or equal to 0. So this is the equation of my circle in what we call general form. Okay, and again, if I wanted to get back to standard form, I would just complete the square, and I would actually get back up here to what I have for standard form. So what I want to do is I want to introduce you to an ellipse. So an ellipse is just a circle with different radii, and they have different values on the denominator. In addition, an ellipse, if you notice, has something called a major axis, and that axis is the longer axis. So we have a major axis. We have a minor axis, which is less than the major axis. We have a focus point. Now, this is something that we're going to talk about, but a focus point here and here, the focus points are always on the major axis. So that's of note to write down. The focus points for an ellipse are on the major axis, always. So not only do I have focus points, which we call C. So this, like this distance from here to here, we call C. We call A being the major axis. So let's say that's A, because that's the major axis. So if this from here to here is A, then 2 of those would be my major axis, and that's where you get 2A. If this is B from here to here, then 2B would be my minor axis. And what we have here is to find the focus point. This focus point, you're going to subtract A squared, which is this distance here. So A squared minus B squared is to find my focal points. So you would either say focal points, focus points, or foci. And then foci is written F-O-C-I, so foci, okay? So this just is walking you through what the focus points have to do with making the ellipse. So this is sort of something that I used to do when I was a kid with Etch-a-Sketch, which is, I don't know if that's even still around, but you would put a pencil here and you would make a circle around these points that are already stationary. Those are focus points. They're not going to move. And you would end up getting a sort of like a squashed circle. And this is just another way. See, when you take your, let's say you had a rubber band or something, you were to take this pencil and you were to circle it around like that, what happens is that you end up with an ellipse. So it's kind of cool. So an ellipse has an equation that's separate than a circle, whereas a circle, you had x squared for a circle. If you remember, a circle was x squared. If the center is at 0, it's just going to be x squared plus y squared is equal to my radius squared, right? And what we wrote that as x minus h, quantity squared, plus y minus k, quantity squared, is equal to my radius squared. The difference between these two equations is that this is a circle with a center at 0, and this is a circle with a center at hk, meaning not 0, okay? But if I were to take my r and I were to divide it through, so meaning I had x squared plus y squared is equal to 1, and then my r squareds would be down here. Notice that for a circle, the two denominators would be exactly the same. They would both be r squared. Whereas for an ellipse, okay, your a squared and your b squared, these are different values. And so that differentiates a circle from an ellipse. Now the a, remember the a value, which we were talking about on the previous screen, the a value has to be greater than b. That's my major axis, okay? So 2 a's is going to give me my major axis, whereas 2 b's is going to give me my minor axis. And in order to find my focal points here, I would go c squared is equal to my a value squared minus my b value squared. And this is the equation to find my focal points. And you're going to need to know that in doing these problems, okay? So this one right here is a little bit different. If you would notice that, oh, let me go back one more time and just remind you of something. If my major axis is on my x-axis, see that major? That's my major axis. If that is on the x-axis, my major axis, the a value, is going to be underneath the x-coordinate. Whereas the minor axis, which is smaller, see how this is smaller than the x-axis going across? The b value is going to be underneath the y-axis, and that's going to give me a horizontal ellipse. So it's going to be a kind of a squashed ellipse. Whereas if I were to look at this equation, you notice how my ellipse is elongated like that. Well, what that means is that my y value would be larger than my x value. So therefore, my a value here for my ellipse is always going to be my major axis. A is always going to be the major axis, but in this case, it's under the y-axis, so my ellipse is going to be basically looking something, let me just exaggerate it a little bit like that, That's my A term here and my B term here. So again, HK shifts my ellipse off the center. So in the previous example, what we saw was we had x squared plus y squared is equal to 1. And underneath that, we had our major axis being under x, and we had our minor axis being under y. And that's the case. This, again, this would be different. This would be x squared over b squared plus y squared over a squared equals 1. And that's with the major axis under y, because that's elongated, that's larger. Now, this example right here is with my center equal to 0, 0, okay? So if you notice that this is another way of writing x minus 0 quantity squared. So x minus 0 quantity squared is just x squared. And y squared is the same thing as saying y minus 0 quantity squared. But if you notice that I moved the center off of 0, 0, 0, 0 being here. So we moved it over h and up k, all right? So in doing that, that means that my center is now going to be x minus h quantity squared and y minus k. That's when you move your center off of 0, 0. So let's practice. Graph the ellipse and find the foci, and basically you're going to find all the parts. What you need to notice for this equation right here is that this can be rewritten as x minus 0 quantity squared over 25 plus parenthesis y minus 0 quantity squared over 9 is equal to 1. What this has done is this has said that because there's no value, no hk, that my center is at 0, 0. So there's my center. Now, here you'll notice that my underneath the x is the larger value, and underneath the y is my smaller value. So that's my b squared, and this is my a squared. So if I want to find a is equal to the square root of this, because we have a squared is equal to 25, so a is equal to 5. So that means that the value, because it's on x, underneath the x, you're going to go 5 both ways in the x direction. 2, 3, 4, 5. 1, 2, 3, 4, 5. So because it's underneath the x, okay, I'm going to go in the x direction, 5 left and 5 right. Because this is underneath the y, I'm going to go up 9, because b squared is equal to 9. B is equal to 3. So I'm not going up 9. I'm going up and down 3. So that means that in the y direction, 1, 2, 3, 1, 2, 3. So that my ellipse now looks something like this. Okay, and so you're going to be responsible for graphing that. In addition to that, you're going to be responsible for telling me what my major axis is. And because this value is larger than the 9, this value is my major axis. So that means that 2a, right, if this is 5 and this is 5, then 2 of that is going to equal my major axis. So my major axis is 10. In addition to that, my minor axis is going to be 2b, and that's going to be, if this is 3 and this is 3, then 2 of those, that's 6, and that's my minor axis. And lastly, you're going to need to know where your focal points are. Now remember what I said is that your focal points, your foci, are on your major axis, okay? So in order to find where my focus points are, I'm going to use this formula, which says c squared equals a squared minus b squared. So to find c, which is the distance from my center to my focus points, I'm going to take a squared, which is 25, and I'm going to subtract b squared, which is 9. So 25 minus 9 is 16. So c squared is 16. I'm going to square root both sides, and so I get that equal to 4. Remember, this is plus or minus 4. So in the x direction, 2, 3, 4, there's my c value right here. That's c, which is 4. And then going the other direction right here, that's my focus point here. That's a negative 4. So that's negative 4, 0, and this is positive 4, 0. So my focus points are at 4, 0 and at negative 4, 0. And you're going to need to write down where your foci are. Let's see what this is. Oh, this is just telling you where your foci are, plus or minus your C value, which we got was our C value was 4. So they were plus or minus 4, comma, 0. So this is just another way of writing, writing that. Okay, so practice problem number 2 says find the equation of an ellipse that has the center at the origin, and my center is at the origin and a focus point at 3, 0. Now what that means is my focus point is my C value and my vertex. So what you have, let me go back to the equation here. What you have are vertices. So here's a vertex, and here's a vertex, here's a vertex, and here's a vertex. This is these vertices are on my major axis, this value and this value. So you would say, well, 5, 0 is a vertice or a vertex, and this is negative 5, 0 is another vertice. 0, 3 is a vertice, and 0, negative 3 is another vertice. So these are my vertex points. But usually when they're talking about this, remember, your foci are always on your major axis. So I always encourage you to graph your equation. So when it says I have one focus point at 3, 0, this is important because it says my center is at my origin. So that tells me this. If my one focus point is at 3, 0, that's C. That's my C value. Then I remember it just sort of mirrors it on the left. So this distance from here to here is 3, and that's my C value, okay? So I know that C is equal to 3. It also says that one of my vertices is at negative 4, 0. So that means that if I go over 1, negative 4, 0, right? And that means over here will be also 4, 0. All right. And that tells me that my A value is equal to 4. And I know that because remember, my foci are always on my major axis. So in the scheme of things, we know that our center is at 0, 0. So we could start off by saying x minus 0 quantity squared plus y minus 0 quantity squared. And this is going to equal 1 because what we've done is we've divided that out. And in the x direction, I have gone 4. So that means that in this underneath here, this is going to be 4 squared, right? Which will be 16. In the y direction, I don't know how far up I went. So in order to find that value, I'm going to use my foci equation, which says c squared is equal to a squared minus b squared. C is 9, so we're going to go 9 equals 16 minus b squared. So if I were to take, let's see, move the 16 over to the other side. So if I were to subtract 16 for this problem, let's see, I'm going to get 7. So I'm out of room here. Let me see if I can move this up. There we go. So that means that b squared is equal to 7. So that means that that's going to be this value here. So in rewriting my equation, I have x squared over 16 plus y squared over 7 is equal to 1. And so this is my equation at the origin of my ellipse. And graphing this, lastly, I would need to go, if this is equal to b squared, that being the smaller value, and this is equal to a squared, I know I would need to go 4 in both directions on my major axis. But on this case, I'm going to go the square root of 7. So approximating that, we'll just say it's around here, taking the square root of 7, and we're going to do this. There's my graph. And this is just another equation of what I just did. So for problem number 3 is find an equation of the ellipse that has one focus point at 0, 2. So I'm going to graph that. So 0, 2 is one focus point. There's my focus point. So down here, I'm going to have another 0, 2. 0, negative 2. My vertices are at 0, negative 3. So this is my A value. So from here to here is my A value. From here to here is my C value. And also 0, positive 3. So realistically, this value and this value, these are my foci, okay? So my foci have a value from my center of 2. So C value is equal to 2. So C squared is equal to A squared minus B squared. So we're going to go with 4 is equal to A. A is 3. 3 squared is 9 minus b squared. So if I subtract 9, I get negative 5 is negative b squared. Divide by negative 1, I get b squared is equal to 5. So in making my equation, that is at the center, I'm going to go x squared. Now in the x direction, remember, if my focus points are here and here, that means my major axis, this is my major axis, is on y, because my major axis is always the longer axis. So when I do this, y squared, and then I set this equal to 1, okay, y is going to be 3 squared, which is 9. So there will be a 9 underneath that, and this b is 5 because it's less than. Okay. Find the equation of the ellipse that has a center at 2, negative 3. Now this center, if you notice, is that my center is now moved off of 0, 0. So right off the bat, if my center is at 2, negative 3, I can start writing the equation of my ellipse as x minus 2, quantity squared, plus, this will be parenthesis, y, see the minus? That'll be plus 3, quantity squared, equals 1. And what have underneath here is what I need to find. So I'm going to graph my center, which is at 2, negative 3. So that's here. And I know one focus point is at 3, negative 3. So 3, negative 3. Oh, so that means that this is my center, okay? This is one of my focus points. So remember that my focus points are on my major axis. Now, so I have one focus point at 3, negative 3. So that means that the distance from here, my center, to my focus point is 1. So C is equal to 1. I have one vertex at 5, 3, 4, 5, negative 3. So if I was at 2, negative 3, and now this is at 5, negative 3, that means that this distance from here to here is 3. So my A value is 3. So that means also that my foci are on my x-axis, which means that my x-axis must be the largest. The x-axis must be the largest axis, my major axis. So this value underneath x is going to be 9. Now for this one, if we know that c squared is equal to a squared minus b squared, c was 1. So we had 1 is equal to a squared, which is 9, minus b squared. So that means that negative 8 is equal to negative b squared, this being 9. B squared is equal to 8. So that means underneath my y-axis, I have 8. I would just also reiterate that if I asked you what the major axis was, you would need to tell me what's the value of the major axis. So remember, the major axis is 2a. And if this value here is a squared, then a would equal 3. So 2 of those would be 6. So my major axis is 6. For my minor axis, that's going to be equal to 2b. And so if b, this is equal to b squared, so b is equal to the square root of 8, okay? And that's going to be the square root of 4 times the square root of 2, or 2 root 2. So 2 of those would be 4 root 2. So that would be my minor axis. Again, just another explanation of what you're seeing. I will point out that for the foci, if you'll notice, that it always goes from the center. So whatever my focal value is, so like for example here, I would go 2 comma, and then this point here would be negative 3 minus 2 root 2, because b, that's my b value. And then this is negative 3, it's one's plus, one's minus to get to this point here and this point. Whereas to get to your focus, you're just adding 1 to the left and adding 1 to the right. For this equation, this one says find an equation of an ellipse that have foci at 2, 0 and negative 2, 0. So if I were to graph 2, 0 and negative 2, 0, okay, those are my c values, okay? That means that c is equal to 2, right? Because that would mean if this is focal value and focal value, they're always on my major axis. That also tells me two things. Number one, because they're equally distance apart, that my center is at 0, 0. So meaning I can start writing my equation x squared plus y squared is equal to 1. Now I know that C is 2. I also have a major axis of 8. And that has to be on the same axis as my focal point. So if my major axis is 8, that's the whole length. That means I'm going 1, 2, 3, 4 in the right direction, which is 4, 0, and 1, 2, 3, 4 in the left direction, so negative 4, comma 0. So my major axis from here to here is 8, but A, which is this distance here, is 4. So A is 4. So we know that in the x direction, if A is 4, and this is A squared on the bottom, that's going to be 16. C squared is equal to A squared minus B squared is the equation for my focal point. So, but I have that, and I know that my foci are at 2. So this is going to be C squared. So 4 is equal to 16 minus B squared. So when I subtract 16, I'm going to get 12 is equal to B squared. And so 12 will be underneath here. So this is the equation for standard form for the equation of my ellipse. Okay, which basically means if I took the square root of 12, I would have that value being 0, comma, square root of 12. And of course, you can reduce that. For this example right here, find an equation for an ellipse that has vertices of 3, negative 4. And I really think that the best way to find these to solve these problems is to make a graph. You have to practice graphing these. Your vertices are at 3, negative 4, so 1, 2, 3, 1, 2, 3, 4. So this is going to be my major axis right here. Major axis is where my major vertices are. So we have 3, negative 4, and then I have 3, 4, 5, 6. So here's another find an equation with vertices, and that's 3, 6. Okay, so what we know so far, whoops, I just want to move, it's not going to work. Okay, so what we know is that my major axis, okay, is this distance from here to here. That's what I know. That means that halfway in between there, I'm going to have my center, and I need to know what that value is. Now, if this is 3, negative 4, and this is 3. Oops, I think I graphed that wrong. Let me regraph that. So if this is 3, negative 4, so 3, negative 4, so 3, negative 4, and 3, 6, so 3, 1, 2, 3, 4, 5, 6, and that's 3, 6, okay? That's my major axis. Ooh, goes like that. So if it's 6 up here and 4 down here, that means my major axis is 10. So that means that half of 10 is 5. So 1, 2, 3, 4, 5. So this is my center, and it looks like my center is at 3, 1. Now I can also find that value, which is my midpoint, by adding my x's and dividing by 2, and adding my y's and dividing by 2. So that means I can start my center, my equation for my ellipse is going to be x minus 3 quantity squared plus y minus 1 quantity squared equals 1. And I'm going to have, now I got to find my x and y. I know that my major axis is 10, which that means if my major axis is 10, then that means that this a value from here to here is 5. And because my vertices right here are on my major axis, that means that 5 plus 5, that means that 5 squared is going to be 25, which goes right here. Now, we also know that the minor axis endpoints are this right here. So let's graph that. So the minor axis points are 1, 1, and 5, 1. So this was 3, 4, 5, 1. So that's 5, 1. So that's my minor axis. So my ellipse kind of comes up and goes down like this, okay? So my minor axis, if this is 3, 1, and this is 5, 1, that means B, this term right here, this value here is 2. So that means that underneath the x-axis, because I'm going in the x direction, that value goes underneath the x-axis. That's going to be 2 squared, which is 4. So this is the equation of my ellipse in standard form. This one right here is your job is to find the center, the vertices, and the foci. You've got to find everything. And it looks like we are going to be completing the square for this problem. Now, something to consider. In all the problems that we've ever done for this, completing the square for a circle, the x squared terms and the y squared terms were always 1. But in this case, you'll notice that my x squared term coefficient is 4, not 1. So what that means is when it comes down to completing the square, I can't have that value next to the x squared term. So I am going to have to factor that out. So let's rewrite this first. So we're going to go 4x squared. I'm going to group my x's. So I've got this and this. So plus 24x and plus y squared minus 2y is equal to negative 21. Now, again, I can complete the square on this part right here because I have a y squared term and a y. In order to complete the square, you have to have a y squared term and a y. To complete the square here, I do have an x squared term and an x. But again, this 4 has to go away. So in order to make it go away, you do not divide it out. We're just going to factor it out of this little part right here. So we have 4x squared plus 6x, and now I'm going to complete the square. So what's half of 6? Half of 6 is 3. 3 squared is 9, so that becomes plus 9. Plus, now we're going to complete the square here, y squared minus 2y, half of the b term, so half of 2 is 1, or negative 1. But when you square that, you get a positive 1, and that equals negative 21. Now remember, because this is an equation, see the equal sign? Whatever you do to one side of the equation, you have to do to the other side of the equation. Now remember when we temporarily factored out this 4? Well, what we actually added to this equation was 4 times 9, which is 36. So I have to add that to the right side because I added it into the left. In addition, I added a 1 on this left side, so I have to add a 1 here also. Okay, so when factoring this, I end up getting 4 times the quantity x plus 3 times x plus 3, which is 4 times the quantity x plus 3 squared, plus y minus 1 times y minus 1 is y minus 1 quantity squared, is equal to, and we have negative 21 plus 1 is negative 20, and 36 minus 20 is 16. So the 16 goes here. Now remember, for an ellipse, this value here needs to be 1. So what I'm going to need to do is I'm going to need to divide everything, not just this value, but everything by 16. And in doing that, what ends up happening is I'm going to get the 1 that I wanted here on the right. I'm going to get y minus 1 quantity squared over 16 here. But on this value, this is the same thing as saying you're canceling this, but this is 16 divided by 4, which is 4. So you're going to get x plus 3 quantity squared over 4. So that this right here is the equation for my ellipse. Okay. Now, excuse me for a second. A couple of things that you need to understand is for this, we have a center now at negative 3. So we're going to have a center for our ellipse. Our center is at negative 3, 1. In the x direction, see, you have to decide which one is bigger, which one's smaller. This is bigger. So this means that this value is my a squared. This value here is equal to my b squared. So that means that a is equal to 4. So that means from my center, I'm going to go 4 in the y direction because that is underneath the y term. That means my b term is going to be 2 because that's b squared equals 4, so b equals 2. So let's draw this. So we start off at negative 3, 1. So negative 3, 1. So there's negative 3, 1. In the x direction, which is underneath the x, I'm going to go the square root of 4, which is 2. So I'm going to go to the right, 2, 1, 2. So that's this point. In the going left, 1, 2, that's where I'm going that way. In the y direction, I'm going to go the square root of 16 because that's underneath the y coordinate. So I'm going to go 4, 1, 2, 3, 4 this way, and 1, 2, 3, 4 this way, so that my ellipse looks like this. All right. So not only we graphed it, but let's talk about what my major axis is. So my major axis is equal to 2a, right? Well, if a is 4, then my major axis is 8. So that means that you should be able to count from the longest part to the end here, 8. So 4 up, 4 down, that's my major axis. My minor axis is equal to 2b, which is going to be 2 times 2, which is 4. So I should be able to count across and then get 4. Secondly, you're going to need to find your focal points, okay? So in order to find my focal points or my foci, I'm going to use my equation c squared is equal to a squared minus b squared. And so c squared, which I'm trying to find, so c squared is equal to a squared, which is the biggest value, 16, minus 4. So 16 minus 4 is 12. So c is equal to the square root of 12, which becomes 2 root 3. Now, in order to find these points here, you're going to have to label all these points on here. So in doing that, you always go from the center. So for this point here, we went -3, 1, right? So this was -3, 1. For my vertices, so this is for my vertices being on my major axis here, this point up here was 4 up. So this would be -3, 5. And this would be -3, let's see what that would be. Down 5, and I was already up 1, so that'd be -4. For this value here, you're going to have -1, 1. And this point here, if this was -3 and I went over 2, that's going to be 3, 4, 5, -5, 1. And lastly, for my focal points, you're going to be putting them on your equation, on your axis here and here. But to get there, remember, you're going to have to add that value. If it's on the y-axis, you're adding that value to the y coordinate. So for this point right here, which is my focal point, it's going to be -3, 1, because you have to add that to your y coordinate, plus 2 root 3. And this point here is going to be -3, 1 minus 2 root 3. So if it's on the y-axis, you add your focal point to your y coordinate. If it's on the x-axis, I would have added it to my x coordinate. So this one right here is a little bit tricky, honestly. Find the equation for the set of all points such that the sum of the distances. So we do have a formula for the sum of the distances, okay? The sum of the distances is equal to 2a. 2a being my major axis, okay? And so what that means is let's graph this. So we know that the sum of the distances from the points, so we know that d1 plus d2, the sum of my distances, and where the distances are coming in to effect is basically when we were having our ellipse, right? And we had our focal points from here to here. We had distance 1 was this value, and distance 2 was this value. So the sum of my distances is actually equal to 2a, all right? And so this is equal to 2a, and let's find these values. So we need to graph this. And so what we know, let's see here, is that the sum of the distances is equal to 12. So I know that 12 is equal to 2a. So a is equal to 6. Now let's graph the points that they gave me, that the sum of the distances is from 1, 4. So 1, 4. So we'll say that's right here, to 7, 4. So there's 7, that's 1, and that's 7, 4, okay? And so what that's telling me is that the center from 1, 4, this being 4, to 7, 4, my center is going to be at 7 minus 1 is 6 divided by 2, so I need to move over, let's see, 2. So let's graph. Let me see what we've got here. I believe that that point is 4, 4, 4, 4. So let's see. 1, 2, 3, 4. So 1, 2, 3, 4 here. 1, 2, 3 here. Because if that's 6, that distance, 7 minus 1 is equal to 6. And so that means this whole distance is 6. If you were to divide that by 2, that means I need to move over to the left 3 and moving over to the right 3. So 1 plus 3 is 4. So that does give me 4, 4. So my equation for my ellipse starting off is going to be x minus 4 quantity squared over something plus y minus 4 quantity squared over something else is equal to 1. So what we know is that the a value is 6. So that means that, what else do we know here? The sum of the distances from the points is always equal to 12. We know that a is equal to 6. So that means that the distance from here to here is 6, but that's not 6. So that means that my equation has to be looking something like this, because from here to here is my a value. This is not enough distance for a. So that means that has to be my b value. So that means that underneath the y coordinate is 6 squared, which is 36. And we know, what else do we know? We know that our b value from here to here is 3. So that 3 squared is 9. So this is the equation of my ellipse in standard form. That's a little tricky. What happens when a line and a circle intersect? This is the last problem. So let's get this started. We see this right here. This is a circle. You may think it's an ellipse. It looks kind of like an ellipse if I had done this. See, look, x squared over 16 plus y squared over 16 is equal to 1. The difference between a circle and an ellipse, this being a circle, is that the circle has these two values are the same. Whereas, remember, an ellipse is going to have one of these values larger than the other. Okay, so what we do know is that this is a circle, okay, and then it looks like my center is at 0, 0, and that I've got to go 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the right, up 4, and down 4. So here's my circle. My circle looks something like this. All right. And this is a line. I know that's a line because my y and my x coordinates are 1. And so this being a line, I'm going to solve for y. So I get negative y is equal to negative x plus 4. I'm going to solve for y. So y is now multiplying by negative 1. Y equals x minus 4. So this is the equation of my line, and this is the equation of my circle. Okay. Now, graphing that, 1, 2, 3, 4, that's my y-intercept. Remember, for the equation of a line, that's my y-intercept. And then the equation in front of the x, that's your mx plus b, your m term. My slope is equal to 1. Okay, so that means up 1 over 1, up 1 over 1. So that means my graph is probably going to do something like that. What's happening here is that I want to know, what are my points of intersection? I do see this one point being 0, negative 4. It sure looks like, it sure looks like this circle is going to intersect right here at 0, negative 4. But I do see that there is a point over here also that I don't know about. So in order to find the equation of my, in order to find the two intersection points that it looks like my graph is showing, is that I'm going to have to solve this system. Okay, so this is solving a system of equations. Now remember, solving systems of equations. Solving systems of equations mean that you know, let's see, the substitution method, you know, the graphing method, which we just did, but it's unclear what the second point is. You've got elimination, substitution, Kramer's rule, which we're not going to use. But for this right here, I believe I'm going to use substitution. Because I've already solved for y, I'm going to take the equation for my circle and plug this into that. So what I have is x squared plus, now I'm going to plug in my y value, okay, which is this right here. And that goes right here. X minus 4 quantity squared is equal to 16. See how I plugged my y value right here into the circle equation. So we have x squared plus, now I have to FOIL that. So we're going to get x minus 4 times x minus 4 equals 16. So we have x squared plus, let's FOIL, we have x squared minus 4, which is minus 8x. This makes plus 16. I'm going to move this 16 to the left, and that makes minus 16 is equal to 0. So what we have now is we have 2x squared minus 8x. These are going to cancel, is equal to 0. I'm going to factor out, it is quadratic. That means I am going to get two answers. I'm going to factor out a 2 and an x. And in that case, I'm going to get an x here minus 4 is equal to 0. I'm going to split this up. I'm going to set both sides equal to 0. So 2x equals 0, and x minus 4 is equal to 0. I get x equals 0, and I get x is equal to positive 4. Now, when I'm plugging those values in, now what I need to do is plug those back into my equation. I'm going to plug them back into my line. So I get y is equal to x minus 4. I'm plugging that back in right there. So not only am I going to plug in 0, but I'm also going to plug in 4. So basically what it looks like is this. When I plug in 0 to x, which is this one right here, I'm going to get something. And then when I plug in 4 to x, I'm going to get something else. Okay? So when I plug in 0, I get y equals 0 minus 4. Well, 0 minus 4 is negative 4. So y equals negative 4. So one of my intersection points is 0, negative 4, which actually we already knew. Now I'm going to plug in 4. So y is equal to 4 minus 4. So y is equal to 0. So when I plugged in 4, I got 0. So what that means is that 4, 0, my actual other intersection point is 4, 0. So we have, we just started, this is a system of equations using conics. So this is kind of cool. This is really neat to be able to take a conic and a line and be able to find the intersection points. So thanks for watching. I hope that helped, and stay tuned for the next lesson, which is on hyperbolas. All right, thanks.